Okay guys, I'm on page 18 of your unit packets and I'm going to be talking about inverse functions today. So let's talk about an inverse relation first. If the graph of a function contains a point a comma b, then the graph of the inverse relation of the function contains the point b comma a. So our x coordinate now becomes our y coordinate. To graph the inverse of a function, reverse the ordered pair of the original function. Should the inverse relation of a function f of x also be a function, this inverse function is denoted by f of negative 1x. So this symbol here with that little negative 1 means inverse function. So whenever you see that, that means it's the inverse. So the key thing that I want to focus on with inverse functions, or how to take inverse functions, is we're switching x with y. And we'll go over an example in a second. Note, the inverse function may not itself be a function. So if the inverse of a function is itself also a function, it is referred to as the inverse function. So let's talk about this graphically. So before, if we wanted to figure out if something was a function or not, we used the vertical line test. And we said if we draw a vertical line through the graph, it can only intersect the vertical line at one point. And if it intersects only at one point, then it was a function. If it intersects at 2 points, it is not a function. Well, now, since we're talking about the inverse and we're switching the x with the y, we use a horizontal line test to see if the inverse is a function. So I do my vertical line test on this linear equation right here, this example y equals 3x plus 2, and I realize that it passes my horizontal test because it only intersects one time for every horizontal line I do. Now if it intersected more than one, then the inverse relation would not be a function. So the function y equals 3x plus 2 has an inverse function because it passes the horizontal line test. Okay, let's flip the page over. So another way that we can talk about if a function has an inverse function is if the function is reflected about this y is equal to x line. So I have this function here, y is equal to x squared. And this, if it is reflected about my y is equal to x line, which is this horizontal dotted line here, if it's completely reflected about that line, then it will also be a function. So here's the reflection. So this pink line here, this red line, will not pass the vertical line test because it does not have an inverse function. So if we were to do a horizontal line test right here, it would intersect at 2 points. So it would intersect here and here. So this is not a function, it would just be an inverse relation. So this is not a function because if we do our horizontal line test, it intersects at 2 points. Okay, so also let's talk about restricting the domain. With functions such as y is equal to x squared, which is our quadratic function right here, it is possible to restrict the domain to obtain an inverse function for the portion of the graph. This means that you will be looking at only a selected section of the original graph that will pass the horizontal line test. So if we're talking about that, I'm talking about all I want to focus on is 1/2 of the graph. So if I were to draw a vertical line, this part wouldn't be here and it would pass the horizontal line test. So you can restrict the domain to do that. Okay. Let's talk about now steps to finding the inverse function. So this is what I want you guys to focus on. This is what is going to be on your unit test. Finding the inverse of a function. So there's two steps. The first step is switch x and y, and the second step is isolate y. So looking at this example here, y is equal to 3x minus 2. My first step is I switch x and y. So this is going to be my x, and this is going to be my y. I switch the positions. And my second step is to isolate y. I want to get y alone. So I'm going to get everything else to the left side of the equation. So I can add 2. That crosses those out. And I get x plus 2 is equal to 3y. And then the last step is I can divide by 3. So I get y is equal to x plus 2 over 3. Now if I were to graph this, it'd be a lot easier if I separate these two fractions so I can easily see my slope and my y-intercept. So I want you guys to get in the habit of that. So this would be y is equal to, this is like an invisible 1 in front of the x. So it's 1/3 x, because that's an invisible 1 there. I wrote it in front of the x because now I can easily see that this is my slope, 1/3, so rise over run. And then plus 2/3 is going to be my y-intercept. So this would be my inverse function. Okay, turn the page over. I want to do an example on page 21. So I'm on page 21, and the directions say find the inverse of each function. And let's look at number 13. I want you guys to try and do this whole page after the video and see how far you get. You can check your answers on page 22. Okay, so this f of n is the same thing as y. So I'm just going to view that as y if that confuses you. And I'm going to change this to x, but you don't have to. I just like thinking, I just want to follow the same steps, thinking in terms of y and x. Okay, so my first step is switch x and y. So that means this becomes x, and right here is going to become y. So that's step 1, and now I want to just isolate y. So I want to get this y alone. So I want to get everything else to the left side. Well, first I have this plus 2 out here, so I can subtract that, and I have x minus 2 is equal to -4 over y plus 2. My y is in my denominator. I don't want my y in my denominator. It's going to confuse me. So what I recommend doing is if I multiply y plus 2 to both sides, then this will cross out and I get rid of my fraction. I'm doing this step because it gets rid of my fraction. So now I have y plus 2 times x minus 2 is equal to -4. I just wanted to get rid of that fraction. And now I want to divide.
Can I get Leo Luna to the main office? Your mom's here to pick you up. Leo Luna to the main office, please.
I'm sorry. You'd think, whatever. Okay. There's no good time to do this. So now I'm dividing by x minus 2 because I'm trying to get y alone. So I have y plus 2 is equal to -4 over x minus 2. And my last step here is -2 to get y alone. And I subtract 2 here. So y is equal to -4 over x minus 2 minus 2. Okay, try a few on your own. Good luck, guys.